Is that it?
Does anybody need to see how I broke down to get negative root 5 and negative 7 root 3? Did any of these cause a problem? Okay. Which one are you having? Which one do you want to see? Are you good? Okay. So, guys, girls, 3 root 5 I leave as is because 3 root 5 is in simplest form. I just found negative 3 root 3. Negative 8 or root 80. I can split that up into 4 root 5, and because there's a negative in front, it becomes negative 4 root 5. 80 splits up into, you can go 4 and 20, 2 and 2, 2 and 10, 2 and 5, and it'll actually give you 2 groups of 2 and then left with a 5, okay? So that's the factor tree. And 2 root 12 actually breaks down to negative 4 root 3. And why is it 4 root 3 and not 2 root 3?
Because you already got the 2 on the other.
So that was the thing that happened in the last class, is that they were a little stuck on, a lot of them wrote negative 2 root 3 because they didn't know what to do with this 2 already out front. This 2 as a coefficient, it's like they just did half of the work and forgot to do the rest of it. So they had a 2 as a coefficient, you putting another 2, you have to multiply it together. So now that we have all of the simplest forms, which 2 combine? What combines? So we'll start from the left. Negative 3 root 3. What do I combine this with? Do I combine with 3 root 5? 4 root 5? Or 4 root 3?
4 root 3.
Those 2 get combined. Why? What makes these significant? Why do I combine them here? They have the same radicand. Did you have a question?
Yeah, I was having a question. The 7 root 3 doesn't matter if it's in front or behind.
As long as it's negative. Okay, because it's negative here. These 2 then automatically become combined because they have the same radicand of root 5. 3 minus 4 gives me a negative 1 root 5. Negative 3 minus 4 gives me negative 7. So to answer your question, Keegan, as long as these are both negative, it doesn't matter which order. As long as your sign is correct, it doesn't matter what order you put them, okay? Good? Any questions on that? Okay?
I feel like we were there and then back and we were there.
This part?
Yeah.
Okay, which one? So did you understand how I got this one?
Yeah.
This one was fine. You need to see this one. This was the root 80.
I just didn't understand how you got this that part, the red part.
This? Okay, so now I'm just adding them together. I have negative 3 and I have negative 4. If I owe you $3, I ask for $4 more. I owe you $7. 7 root 3. I have $3, I asked for $4, I now am down $1. Right? I'm just combining them based on the ones that are like terms. I'm collecting like terms. These are like terms, these are like terms. Because of the radicand. It becomes an adding or subtracting question, right? We're not multiplying anymore. We're adding or subtracting, okay? That good? Okay, the only other one here quickly, 4c, this is an easy one. What's the square root of 4?
2.
What's the square root of 9?
3.
What's 9 or 3 times 4?
12.
Okay. Are my radicands the same?
Yep.
What's 2 minus 12?
Negative 14.
Minus 10.
Oh, yeah.
Right? Okay. As long as your radicand is the same or identical, that's when you can add and subtract. Okay? So let's look at multiplying now. If I gave you a multiplication that looked like this, 3 and x plus 3. How would you multiply this or simplify this term?
Multiply 3 by each variable.
3 by each term, right? I could use my factor tree. X and 2, 3 times x is 3x, 3 times 2 is 6. My answer is 3x plus 6. The exact same thing is happening to this term, only now I have I have radicals. Okay? I can create my factor tree using these terms. So now I want you to solve, and I want you to simplify. Make sure that it is broken down into a simplest radical form. Okay? Give it a try. I would, if I were not sure where to start, I would draw my factor tree. This is a 9 cube root of 2w. This becomes a cube root of 4w. And this is 7 cube root of 28. Then I would create my factor tree.
Looks like I'm still